Alright, so we're going to be looking at problem 1 from homework 8. So this problem concerns a velocity function, v of t equals 40 plus 20 sine squared of t. And we're given a formula in the problem which lets us simplify this to 40 plus 10 times 1 minus cosine of 2t. And so the reason why we want to use this formula is because it will make it a bit easier to use the fundamental theorem of calculus for this thing. So we're asked to find what is the average velocity of this car between 0 and 2 pi. So the formula that we have from class is that the average of a function is equal to the integral of that function from 0 up to 2 pi. So we have 40 plus 10 times 1 minus cosine of 2t divided by the length of the interval. So in this case, 2 pi minus 0. So now we need to calculate this antiderivative. So what do we get? Well, when we integrate the 40, we'll get 40t. And then when we plug in 2 pi and 0, we'll get 80 pi. Then we have plus, when we integrate the 10, we'll get a 20 pi. Then minus integral from 0 to 2 pi of cosine 2t. The antiderivative of negative cosine is a 1/2 sine, with a negative sign still. And we evaluate this from 0 to 2 pi. Then we divide by 2 pi. Okay, so now if we evaluate this, we'll get 100 pi. Notice that when we plug in 2 pi to the sine function, we get 0. When we plug in 0 to the sine function, we get 0. So it's 100 pi divided by 2 pi, which simplifies to 50 miles per hour. So this is the car's average velocity. Now part B asks us to calculate this in a different way. So remember, if we know the distance function for this object, then we had a formula to find the average slope of the distance function, and that was the average velocity. So the first thing we have to do is find a formula for the distance function d of t. And how do we do that? Well, we need to find an antiderivative of this function here, b of t. But notice that when in part A, we actually already did this, right? Because we had to do that when we evaluated this thing using fundamental theorem of calculus. So we already know that an antiderivative of this function is 50t minus 1/2 sine of 2t plus some constant. So this is an equation for the distance. So the average velocity is going to be equal to the average rate of change between these 2 points, which is given by the slope of the secant line, which is d of 2 pi minus d of 0 divided by 2 pi minus 0. And so notice that this is actually exactly the same calculation that we already did. We'll get 100 pi. Sine of 2t is 0, no matter whether we're at 2 pi or 0. So d of 2 pi will have a plus c, but d of 0 will also have a plus c, so the plus c's will cancel when we subtract these two. And it turns out that we essentially did exactly the same calculation. So we see that both methods are essentially the same. And so this hopefully gives you some more intuition for why this average velocity formula using the integral is correct.